Thank you. Hello, everyone, and welcome to our Q2 Sectigo Pulse webinar. I'm Megan Murphy, Marketing Assistant at Sectigo, and I'll be moderating today's webinar. Presenting with us today, we have Sectigo's Chief Compliance Officer, Tim Callan. Hi, Tim. How are you?
I'm doing okay.
Joining Tim will be CTO of SSL at Sectigo, Nick France. How's it going, Nick?
Nick, you're on mute because the technical problems continue. Once again, apologies to the audience. Nick may be stuck on mute.
Okay.
All right, well, let's let Nick try to get himself off mute in the interest of things happening here. There you are. Hi, Nick.
Good afternoon. Sorry, yes, I was muted by the moderator and unable to unmute myself, so it wasn't the usual Zoom excuse of being able to not find the button. So
Gotcha.
thanks, Megan, and afternoon, Tim.
Yeah, but can't find the button, so we already covered that base. All right, so sorry for all of the technical issues. We've all been there with this world of virtual meetings, but we'll keep moving forward. So shall I take it away? So
Yep.
today's agenda, there's 5 things we want to cover today. First of all, we just want to talk about certificate agility. Certificate agility is an important new initiative that a lot of enterprises are paying attention to, and we want to walk through what it means and why it matters. And why it matters is actually gonna directly affect the other 4 items on the agenda. So we are talking about fields that have been removed from Sectigo public certificates and more fields that are to be removed. This is a good thing to be aware of. It shouldn't affect the operation of your certificates in any way unless you're doing something highly unusual, but it's good to know that it's coming. This is the last time we will talk about the Camerfirma trust deprecation. It is complete, and we'll tell you what's up with that, and then we won't discuss that again starting next quarter. There's a browser root cleanup that is going on that could affect you and is worth understanding what's happening. And then we just wanted to give you an update on quantum ready certificates because it's been about a year since we talked about it last. So with that, what is certificate agility? And this is a thing that Nick and I think, can wax eloquent on for a long time. So we'll try to keep it reasonably crisp. But certificate lifespans are dropping, isn't that right, Nick?
Yes, indeed they are. We've mentioned this before, as you've said, but we know we're already down to just over 1 year on regular service certificates, and we believe that it's going to go lower. I mean, it's a positive thing, really, although it is challenging. But we definitely see that it's 397 or 398 days is not the final low limit, we think.
Yeah, absolutely. And this is mostly affecting, obviously, public SSL, but it's a trend you see across other certificate types as well. And it makes good sense. Like it's actually a smart thing to do because there are a lot of reasons why certificates are vulnerabilities, and the shorter lived they are, the shorter the potential time that vulnerability exists. If somebody, let's say, stole your private key and you didn't know it, then once that private key doesn't matter anymore, its theft also doesn't matter, right? As an example. And so shorter certificates are generally a best practice, and we're seeing all aspects of digital certificates kind of drive in that direction, and for very good reasons. But the other thing that's going on is that there has been an increasing need over the years for enterprise to be able to swap out certificates very quickly. Once upon a time, let's say back in the 2000s, you could install a cert and be pretty confident that it was going to be okay for the duration of its term. And more and more, that's proving not to be the case, that certs have to be swapped out. And they have to be swapped out for a variety of reasons, right? Exposed private keys is a perfect example. The CA browser forum rules require that if a CA becomes aware of an exposed private key, then it must revoke that certificate within 24 hours. And so if your private key is exposed, you might not know about it, and you might not know about it until your certificate suddenly isn't working. So, that's an example of something that's happening with increasing frequency. Certificate misissuance. Nick, you remember the 63-bit serial number entropy.
Yeah,
Tell us about that.
yeah. So a fairly popular CA solution, the certificate authority software, had what seemed to be a fairly minor software bug in it, that it was generating serial numbers with one bit too few of entropy, of randomness. Right. So the serial number was 63 bits instead of 64 bits. And by the letter of the law, the guidelines, the industry, that wasn't correct. Now, whether that could actually mean it was a real problem or a real vulnerability was largely not the problem. The fact was it wasn't correct. And what the upshot was is that millions of certificates were, effectively needed to be invalidated, needed to be revoked and reissued in a fairly short space of time. This wasn't something anybody could have predicted. This wasn't something that, could be fixed in a single location. This was something that had to be fixed by a mass revocation event, as you said, and the reissuance of millions of certificates.
And this was something that nobody was expecting, right? And yeah. and these misissuance events, they take many forms. They go on all the time. And CAs are revoking batches of certs all the time. And sometimes they have an opportunity to give you notice. You might get 5 days notice. Sometimes they have no opportunity to give you notice, like in the private key example, and they just plain have to be revoked. So, so every certificate subscriber, regardless of the CA, needs to be prepared for the possibility that on any occasion, any cert you have might have a forced revocation that occurs from the CA about which the CA has no choice, about which the CA has no freedom to choose. And that's a real thing. There's another one is 0-day vulnerabilities, and the case study in this is Heartbleed. So once again, Nick, why don't you remind everybody what happened with Heartbleed?
Yep. So Heartbleed was a software vulnerability in an incredibly popular piece of software called OpenSSL, which ultimately powers vast percentages of the internet, of the web, in terms of handling SSL and TLS. And a vulnerability was discovered in it, and it was a common type of software vulnerability. It was discovered, and it basically meant that an attacker could craft some requests to your web server, for example, and through the special crafting of these requests, receive back your private key, which is obviously the private key that you don't want to expose, and
Right.
and that's really the end. So it was remote access to private keys, essentially. So it was the worst kind of vulnerability. And as you said, Tim, it came out of nowhere. There was no predicting this. OpenSSL is an open source piece of software, so bear in mind this particular feature, this bug, and the source code to OpenSSL has been out there and exposed for anybody to look at and anybody to see for a very long time, and it still took a number of years for that to be discovered. And that's what we mean. 0-day vulnerabilities means it's day zero. It happens without notice, without warning, and there it is. And it was a catastrophic one.
And the thing about Heartbleed was, as soon as everybody knew about it, and that included people who would seek to exploit it. So at that point, once your patch was in place, you then had to go back, and every cert that had been in production prior to patching needed to be treated as insecure. Another great example of that was the Debian vulnerability that came about, I'm going to say, around 2010, 2011. It was the same kind of thing, where all of a sudden it turned out that people came to realize that every cert that had been issued on the Debian operating system for the past year essentially had a predictable private key. And if you had one of these certs, you couldn't
had
use
to
them
replace
anymore. Yeah, pure and simple.
So these kind of vulnerabilities that we don't know about for the longest time, they sit there undiscovered, unknown. They crop up, and like you said, Tim, is as soon as it's discovered by everybody. It's a global thing, and every single certificate, and you don't necessarily know. I think part of the problem is you wouldn't necessarily know if your certificates or keys have been affected. There's no indicator that says whether it's bad or good. You basically have to replace it out of a sense of caution almost, if you ever had it anywhere near a system that ran this particular piece of software, which was most people at the time.
Right, absolutely. And so that's those things happen, and there's no predicting them, and it's not that somebody did something wrong, right? It's just well, somebody in the world did something wrong, but it's not that you did something wrong as a subscriber. It's just that doesn't matter. Things happen and you have to deal. Advances in cryptography occur. So everybody had a scare a few months ago, 2-3 months ago, when someone named Klaus-Peter Schnorr put out a research paper that suggested that perhaps RSA keys could be broken at a much faster rate than was previously thought possible. Now, I think that was vetted by the academic community, and the ultimate conclusion we came to was we don't need to, RSA isn't broken today. But in the beginning, when this new technique was revealed, nobody was really sure. And so what if it had turned out that RSA was essentially useless, or at the key bits that we've all been using was essentially useless? And that was at least a possibility. It didn't happen in that case, but it was something that people took seriously. So
yeah, and it's something that's very likely to, that one is something that I think is kind of scary to, well, probably to you and I, Tim, and in relation to the final point you're about to get onto is because people are researching this all day. I mean, it's beneficial to us to research these things, and mathematics and cryptography. And if you look back at a lot of the breakthroughs that have been made, they sometimes come on quite rapidly, and they're not necessarily predictable. There's certainly researchers looking at how to factorize prime numbers, which is the RSA attack ultimately, and they may just be successful today, tomorrow, and as a side effect, the web PKI has consequences. Obviously, things like that have wider ranging impacts globally, but it's something that isn't going to stop, and we're not going to be able to predict.
Yeah, and also these things snowball, right? Because there's a whole interconnected academic community of people who are interested in advances in cryptography. And if somebody shows a new idea or a new technique, several dozen people who are very expert at this around the world sit down tomorrow and try to see if they can improve on it, right? So that is always a risk. That's a thing that can happen. And then either way, we know it's coming with quantum computers, and we'll get to quantum computers later, so I don't want to belabor that now. But as quantum computers come, our certs are going to have to change, and we have a whole section on that. So when you put all of these things together, what this states is that today's enterprise really needs to engage in something called certificate agility. And certificate agility is kind of take the concept of crypto agility and apply it to your certificates. So crypto agility states that cryptography might change at any time, and we have to be able to update our cryptography to make sure that what we have is always current and reliable. And part of the way we do that, since certificates govern and control the vast majority of the cryptography that is used in our modern systems, then in order to really have crypto agility, we must have certificate agility. And certificate agility, as you see defined in green, is the ability to replace any and all certificates in your environment at any time.
Yep.
So any day I may wake up and I may become aware of the fact that some subset or the entirety of the certificates I'm using must be changed. You were going to say, Nick?
Yeah, I was going to say in its simplest form, and I have some good news I'll share in a second, but in its simplest form, it's preparedness. It's a plan for preparedness. We've just listed off all the issues that we know about, right? That some of them are ones that everybody may have heard of, some are more obscure, but we know to an extent what the problems are that are going to happen. We don't know when they're going to happen, but we know these are all possibilities, and in some cases very likely to happen. And so it's essentially a preparedness plan to deal with those eventualities. The good news I was going to share is I know you and I have been talking about this for some time, but I had a call with a customer earlier today, based in Europe, and it was the first time that I've had an enterprise explicitly explain to me that they not only have a cryptographic spec and requirement for how they use cryptography and particularly certificates, but they actually had a concrete plan in there and a concrete requirement to essentially assure certificate agility, that they could replace any of all of their certificates within 2 days.
That is fantastic.
I am happy that this is starting to break through into, and this is a customer that we've worked with for a long time, but I haven't approached on this in any time recently. So I think the news is starting to spread.
That's good, and that's a best practice for sure. And then I listed some of the things that you need your certificate agility plan to provide for, right? It needs to be error-free. You've got to make sure that when your certs are updated, they're updated correctly with the right cert and it's actually done and they're installed right and all of that. It needs to be immediate or very close to immediate. I would say all the certs in the organization in 2 days definitely qualifies. Needs to be controlled down to the precise at the level you need to do. Oftentimes when this occurs, I don't need to replace all my certs. I need to replace these 7 certs. They need to be the right 7, and it needs to be those 7. So be able to have that level of precision so you don't have to blow up a whole environment if there's no need. The ability to handle any volume up to and including all your certs, and the ability to verify that it happened correctly. So think of those as your criteria when you're working on your certificate agility plan.
Yep.
So what do we suggest, right? How do you get there? How does certificate agility happen? First one is think about certificate automation. Like at the end of the day, the only way this can be done is if you have something automated, right? You have something that can take a set of certs that you select and can automatically provision a new cert, order a new cert, either from your public CA or from your own private CA, and install that cert. And that the whole thing can be done programmatically. And in the absence of that, you're never going to get to true certificate agility. So that's the key point. And then you have to know what you have, right? You can't swap out your certs if you don't know that they exist. And we see this all the time. People have certificates that they're not aware of. They have rogue certificates that get introduced to their environment by development organizations, by outside firms that are hired by various departments to work on things, by employees who just don't reveal what they're doing through centralized IT, and then they find out about these certificates the hard way, either because there's an expiration event or because maybe they install an automation platform and it goes and does discovery and says, look at all these certs. So knowing what you have, inventorying the certificates in your environment and staying on top of that inventory is an absolute must. And then the last one is what Nick talked about. Have that plan. Like have your explicit rapid replacement plan. You say, what happens if an event occurs? How do we swap out our certs quickly? And how do we, if necessary, swap out up to and including all the certs in our organization, or any cert in a given environment, or any cert of a given type, right? And being able to do things at that level and know what you would do, right? Ultimately, it's like saying if I got a phone call right now and there was an existential threat to my PKI and I needed to change every cert I had, what would I do? And that's the plan that you should have in place. And if you do those things, if these 3 things are done, then you really are at least well on your way toward a total certificate agility profile.
Absolutely. And I would say, I think the third item, the rapid replacement, really is a result of the first 2, right? I mean, and usually people tend to look at the inventory first. You want to find out what you have. An automation, we've said it time and time again, is really the only way to do this. Everybody today is handling exponentially larger volumes of certificates than they have previously, right? It's not just websites, it's your authentication, it's your Wi-Fi, your VPN. Everybody's working from home nowadays, so that you've got that to factor in. There's just simply such a high volume of certificates to be dealt with that you can't handle it manually. Absolutely there may be manual exceptions. As much as we have these almost absolutes in here, I think everybody is understanding that this isn't going to be 100%, and certainly not quickly. There may be manual exceptions. You may have air gap systems and various edge cases, and they're okay as long as you have a plan for rapid replacement. As it says, it doesn't need to be 100% automated, but you've got to try and get there, as I'm sure with everything else that you have within your IT organization.
Yeah, absolutely. So that's one of the items. Let's talk about removal of fields. I'm looking at the clock. Let's keep moving. Like I said, Nick and I can talk about that forever. Removal of fields. So Sectigo has been programmatically simplifying the information that is in our certificates. And the basic philosophy here is that anything that is sitting in your certificate that doesn't need to be there is a potential liability for the subscriber. Because if there's some kind of problem, then, if there's a problem with that field and it's in your cert, then you have a problem. If there's no problem with that field, you don't. So let's talk about a few things that are going on. And the first one is probably the OU field. OU stands for organization unit, and the OU field is embattled, let's say, in the browser community. It is a legacy field that was used for management in the past. It goes way back to the early days of SSL. And the trouble with the OU field is it's essentially unauthenticated, which means that there could be information in the OU field that might be potentially misleading about the identity of who owns that cert. And even if you as the subscriber, as the certificate holder, are not intending to mislead, if there is a word or a name in that OU field that could be misconstrued, you might be misleading even though you don't mean to. And so OU fields are going away. It's just a matter of time. They are. The present draft ballot that is undiscovered, that is in discussion in the CA browser forum, would prohibit any certificate to be issued with an OU field starting September 1, 2022. I believe that that is the outside date that OU fields will still be viable. I can't imagine them being viable beyond September 1, and it's even conceivable that it could be earlier than this date. Let's say it probably winds up being September 1.
Yeah.
Go ahead, Nick.
I was going to say I'd suggest it may be. I think we'll both agree on the discussions that are happening, but it may be like one of these changes that we've talked about before, particularly the change of the shorter duration of certificates. That while there can be a CAB forum ballot and there can be discussions there, it may just happen that one of the root programs makes their own decision about sunset dates or whether these things are allowed anymore. And so there is always a possibility of a much shorter deadline on the OU disappearing. And I think, as you touched upon, and one probably important point to manage with this is the other fields that we'll talk about in a second are less consequential in some aspects. I think with the OU, the concern that is held a little bit out there is what you touched on, Tim, which is management. So OU, organizational unit department, there's generally nothing wrong with having a certificate that has OU equals IT department. It's a certificate that's managed by the IT department. The problem is that information isn't externally verifiable. We can verify a company name, an address, a city, a state, a country, but you can't verify an organization has an IT department. There's no requirement to do that. And so the information really isn't verified, so has no place in a public cert. But what a lot of organizations were doing was using that field to hold identifiers that are only meaningful to them for management purposes, putting department codes in there instead, which is arguably even worse, but it also means that that field is relied upon by certain solutions and software and such. And so I think it just bears well to be repeated that this is something that may be of concern if you are using that field for management. A lot of people maybe don't care, it doesn't matter, perhaps they don't even put it in certificates anyway, but it's also something to bear in mind if you do use that field for management.
Yeah, most enterprises won't be using that, but here's the thing, and we'll get to this when we get to the recommendations, which is you've got to understand that OU fields will go away, and if there's a dependency on OU fields being in place, you have a long time. You've got a year to remove that dependency. But if that dependency exists, create a project and get rid of it. Because when the OU fields go, they have to go, and no CA is going to be able to make an exception for you. That's just not how it's going to work. Now, there are also some fields that are available for TLS certs, but they don't need to be there. And it's not a technical requirement. It's not a compliance requirement. It's just a field that you can have if you want. And so, because as I mentioned before, these represent exposure. Every one of these is exposure. And so in the spirit of limiting exposure to the full degree that we can, we have made a policy decision that every field that doesn't need to be there won't be there. So for example, we've already removed street address and postal code. And, I think that went without a hiccup. Anybody even barely noticed that. The next one that's coming is that we will be removing the locality field when the state or province field is present, because the rules state that you don't need both. You can have locality, you can have state or province, but if you have state or province, you don't need locality. So why would we have it? It's just more exposure. And you can think of that as the general principle. that we'll be exploring the SSL certificates you get in their various forms, your EV and OV, and looking at what's in them and taking out anything that doesn't need to be there. And in the event that you're doing something really strange, like depending on the presence of that locality field, then you need to stop doing that. I think I probably talked about all of this. We did remove the street and postal fields. They were removed in March 2021. They are still authenticated because the CA browser form rules require that we authenticate it because of the AV and OV cert. We got to know that's the real organization. They don't have to be in the certificate. They just have to be in our records.
Yes.
And so we have them. We know what they are. That's what needs to happen. They don't need to sit in the cert. So they're being taken out. And that's across all public certs, all brands. And it didn't require any change on your end. So what are the recommended actions? It really comes down to OU fields. So when you look at everybody here, go away and satisfy yourself that OU fields are not something that your organization depends on. And this could be a bunch of things. It could be technical. I have software that's looking for the contents of this field, and based on the contents of this field, it's behaving differently. And if there's no contents of the field, then it shuts down. That would be technical behavior. Process behavior. We look at the OU field in order to determine which budget to put this cert against, right? There's other ways to do that. Use one of those other ways. You have to stop using this. Or management, and I guess that would be management and accounting, but process behavior would be something similar. We look at the OU field to determine where to provision this certificate. Well, you got to find another way to do that. So those are going to be the three areas: technical, process, management, accounting, where this might trip you up. And our recommendation is go satisfy yourself that the OU field is not being used for any of these purposes. And the best way to really prove that is start ordering certs without OU fields, right? And if your certs have no OU fields in them and you're not having problems, then guess what? You've proven it.
Exactly.
And so our recommendation is go do your homework to make sure that you're not going to blow something up. After you've done your homework, strip the OU fields out of your certificate orders and get certificates that are clean of OU. And if there are any problems, you'll find them. And do this in advance.
I was going to say, I think what I'd add to that is just that we understand, as I said, that OU is often used for management. You know, you said it, Tim. That's what people use it for, and testing without is obviously critical. But I could understand why that was done. You know, especially if it's a legacy system where there was very little choice. But as we kind of talked about a little bit in our agility presentation, is there are management tools out there nowadays. You know, there are options, whether it's from the CA that you get your certificates from, or whether it's a third-party solution. There's no need, I think is what I'm saying, there's no need to rely on the OU field for management, because there are vastly better solutions out there for certificate management which don't rely on OU fields in certificates. And so, as well as making sure you're prepared, now might be the time to investigate a better, a bigger, or an alternative solution to whatever you are using that is perhaps causing your reliance on this field.
I think that's a great point, Nick. So the Camerfirma trust deprecation. Let's make this real fast. We want to put a punctuation mark on this one. So Chrome and Firefox deprecated trust for Camerfirma in April of this year. It was Chrome 90 and Firefox 88. It was because there were a lot of problems over time. This was a public CA in Spain. And it is the third trust deprecation since 2019. This has already occurred. This is in the past. If you were a Camerfirma user, you found out the hard way. If you're not a Camerfirma user, you never will be. It's just something to be aware of. So why does this matter? It matters because root distrust does occur, or root expirations do occur. If we recall last summer, we had a root expiration. And under these circumstances, again, what does this mean? It means we need to be able to adjust. It comes back to certificate agility. So what are your recommended actions? First and foremost, this is one of the other reasons that you need to make sure that you have certificate agility in place. And we just can't say that often enough. And then the other one is you can pay attention to your CA's reputation. If you really care, and most people don't because these deprecations are few and far between, but if you really want to belt and suspenders it, there are resources available. And it's things like Bugzilla, bugzilla.mozilla.org, or MDSP, mozilla.dev.security.policy. And these are the places where the public CA community talks about matters and issues with public CAs. And if you got the cycles, if you're an SSL specialist inside your organization, it's good to familiarize yourself with these online resources. These are how the industry talks to itself. It's very public, and there's every reason why you can watch them and see what's going on. So it's good practice for somebody if you're specialized and you can fit that into your weekly agenda or your weekly schedule. It's a good thing to do. Pretty quick. All right.
Yep.
Browser root store cleanups. So again, along the lines of roots and agility and all the rest, there is a root store cleanup that is going on at Mozilla now. So tell us about this, Nick.
Yeah, so periodically, the good folks at Mozilla do a CA survey, and it's basically just a questionnaire that they send out to CAs in the root program. Just, often for various questions about the direction they might be going in, or actions they may be thinking about taking. The most recent batch of survey questions was sent out, or was sent out in April for a May reply. And one of the questions that was asked was about any impact to the CA it might have if Mozilla would start to remove older routes. Now, there was a few clarifying questions. You can actually see the responses to the CAs, but basically I think what Mozilla are trying to do is to clean up their root store. So what they're looking to try and do, and just to be clear, this isn't definitely going to happen yet. It probably is. Let's be completely honest. It probably is going to happen in some form. But the part of the reason it's in the survey is it's kind of Mozilla's way of saying, hey folks, we're thinking about this. This is something we want to discuss. Let's talk about it and let's see what we can do about it. And what they would like to have is all the routes in their trust store be generated and managed under certain conditions. And as you can see from the top of the slide, there's kind of two date cutoffs they're looking to try and introduce, and basically say they don't want to have remote routes that were generated before 2006, or ideally no routes generated before 2012. And the reason for those dates is that firstly the EV guidelines were introduced, and then secondly the baseline requirements were introduced, and they're kind of better documented processes on how these routes should be generated, managed. And ideally, you can see an audit trail from when those guidelines were introduced, on the route all the way up to the present day. And you can see this continuous chain of audits that says everything is good. So it's really a cleanup exercise that is under discussion. And again, Tim, as you just mentioned, the Mozilla group is the best place to witness this public discussion and join in if you feel you need to. I think if you look at the responses, though, there's a couple of points really. Is one that many CAs, and I think Sectigo to an extent are concerned here as well, like all the other CAs are, is that removal of existing routes is, especially legacy routes, is potentially problematic because those routes are relied upon by a lot of devices and a lot of platforms. I think what Mozilla, they do understand, but they perhaps need to listen again on, is that their root store that they curate, because they're an open source organization, but they have the staffing to curate this root store, if you like, and they have people that look at the audits and review and answer questions and do all of the good stuff that the Mozilla staff do. That root store very often just gets copied into places. Okay, you're building a piece of software, you need to trust certificates for TLS. Oh, do I go to the effort of building my own trust store, or should I just grab the Mozilla one? A couple of files, download it and use it. Now that's great because there's an open source solution they can do that from, but it's also bad because there is a lot of work behind it. There's a lot of interpretation. It isn't just a case of copying a file. And I think Mozilla actually posted a blog recently, probably as an upshot of this discussion, explaining how that was a bad idea and developers shouldn't really do that. But I think the fact is that they have, and there are a number of places the world over where there are old devices that aren't going to get updates, that are still reliant on if you like, legacy routes that Sectigo and other CAs operate. So there's always concern when this, someone says, let's get rid of the old routes, because as much as we need to keep pace with modern standards and make sure everything is more updated and arguably more secure, then there is still the fact that we do have a wide number of legacy devices to support and a lot of customers that may be reliant on older routes. So it's not something I think anybody objects to. I think it's more that we need to have a sense of caution when we're doing it, and we need to think about making sure that CAs can get newer routes included much more quickly than the process normally takes today. So a cleanup exercise, mostly for the CAs, that we need to, we need to engage with Mozilla on and work with, as we are doing. And I think what we'll see is more CAs including newer routes and agreeing dates at which older routes are going to be, sunset and then eventually deprecated, so that we can move forward. A kind of a certificate agility, but on kind of a longer time scale, I would say.
Right. But even then, this comes back kind of the certificate agility point, which is somewhere along the line, when a route's deprecated, one day it works and the next day it doesn't. And if you happen to find yourself caught with certificates that suddenly aren't behaving as expected, then you need to be able to respond to that. So yeah, they're not gonna, hard to imagine any of these routes goes away this year, right? But somewhere along the line, that event does occur. And
yes,
when that
these
occurs,
changes are going to happen, and you need to be able to do something about them. You need to be able to adapt, as you've said. If new routes are used, if your CA says to you, hey, we're issuing from a different CA now, everything is good, you're still going to get trusted certificates, but you need to adapt. You need to be able to make sure you're installing these things properly. And I think the two recommended actions that we have here speak to that. So agility, we've said it a lot this quarter. I'm sure we'll continue to, because it's critically important. But make sure you can update things quickly and easily. If your CA says new chain, new routes, new certificate, you need to be able to roll with that. And it isn't particularly challenging if you're doing everything correctly or sensibly, but you need to be able to do it. And the second thing I think is check for this reliance on old routes. Okay, if you are a modern software as a service provider and you only support super modern browsers and you're on the cutting edge of client side user interface and user experience, you're probably not going to have too much of a problem. You're expecting your customers to use the latest version of Firefox and Chrome and Edge and everything else. That's fine. You're probably unimpacted. If you're an enterprise that happens to have a lot of old devices, the kinds where your IT admins roll their eyes because it's some hideously old version of Windows or Linux that you can't update and you can't patch, or you have embedded devices out in the field, they're the areas where you might need to look at this. You need to make sure that if you're following certificate agility and if you're updating your certificates, these old devices can handle it. Your fleet of smart TV clients that haven't had a firmware update in 8 years, are they going to still be able to work if you have to roll to a new certificate on your main streaming server, as an example? So it's really just to have a look at your own infrastructure and make sure that you're not going to have any problems. But I would argue that this is all really part of the whole agility program anyway.
Yes, agreed. And most people won't have a problem. You just don't want to be that person who does, right? And again, we saw with the ad trust expiration last summer, we saw that systems that people expected to be perfectly fine turned out not to be fine. And because people sort of had this idea in their head, oh, I know I'm fine, they didn't bother to do the homework to really figure out what happened if this route went away. And then they were surprised when this problem occurred. So one of the things that's connected to that is don't just sort of blow this off and say, it won't affect me. Actually do your homework and know that factually.
Yeah, exceptions in many of these cases of rule changes and route deprecation and things, exceptions are incredibly difficult to outright impossible in many cases. So you can't always assume that with the best will in the world, we would want to be the best CA, we would want you to be the best customer, we could have the greatest relationship ever, but there are situations where your CA may not be able to help you. So you can't assume that you'll always be able to get out of a jam by a bending of the rules, or not even a bending of the rules, an exception to the rules. They don't really exist anymore. So prepare on that basis, and hopefully there should be no problems.
They certainly don't exist in the case of a root trust going away, because that's it, it's gone. nothing we can
Once
do.
it's gone, it's gone. Yeah, exactly.
So just a reminder, we've talked about this in the past. So if you've been joining us on a regular cadence, you will have seen this, but I want to make sure everyone's up to date on what's going on with this, which is we've all heard about quantum computers. Quantum computers are coming. That's a picture of a quantum computer over to the right there. It kind of looks like a golden chandelier. And what quantum computing does is rather than having discrete 1-0 bits like we have with traditional silicon chips, we have these quantum bits or qubits, which can be 1 and 0 at the same time, essentially, because it's quantum physics. That's how quantum physics works. And because of that, they work in a fundamentally different way. And the general promise of quantum computers is that they will just be much faster than traditional 1-gate, 0-gated computers. But they also are extra special much faster at certain specific tasks. There are tasks that are orders of magnitude, many orders of magnitude faster on a quantum computer than an equivalently powered binary 1-0 gated computer. And as it happens, one of those or two of those are the encryption algorithms that govern 100% of encryption that's done through SSL certificates. So there's this thing called Shor's algorithm, and Shor's algorithm basically shows how a quantum computer can do things much, much, much faster than it used to be. And so this table is from NIST, right? National Institutes of Standards and Technologies. And you'll see RSA and ECC, which sit in the middle of this table, have Shor's algorithm is what governs them. And as a result, you can look at the time it would take a quantum computer to crack these things, and they're all very, very doable. You can have a 2048-bit RSA key, which is probably what you're using today, and in one day, it'll be able to be cracked once quantum computers have reached their critical mass point. And so essentially what it means, from pragmatic terms, is that RSA and ECC encryption, once quantum computers are fully engineered, once they are mature, RSA and ECC will be useless as encryption algorithms. And we as a society will need to move away from them. And so what do we do? What do we use instead? And NIST is leading a global search that is a combination of academia and industry working together to find new algorithms to replace RSA and ECC. And this has been going on for several years. We've been covering it as it goes, so you may have gotten updates from us at the past. At this point, they're down to a short list of 9 candidate algorithms. 4 of these are what they call finalists, and 5 of these are what they call alternates. So the basic idea is that finalists are things that look like they're meeting all of the criteria. So the main criterion is Shor's algorithm can't defeat them, and they're looking for that to be mathematically proven, right? They want people to mathematically prove that Shor's algorithm does not work against these things. But then they also need to be checked out for other things, like they need to be pragmatic to implement. They need to be fast enough to operate that we can use them in our production systems that sit on our servers and it'll really work, right? And things along those lines. The encrypted data need to be small enough that we can push them across our internet connections and they will really work. So that stuff's got to get checked out too. So these 4 finalists are there, and the 5 alternates are there in case the finalists really fall apart. We've got another set that's being vetted as well. And at the end of the day, NIST would like to wind up with an unknown number, but more than one algorithm that we can all standardize on. And it'll be done when it'll be done, but they want it to be done in 2022, and they ideally want it to be done in the first half of 2022. So that's how that train is going. That, NIST would like for a year from today, when we're doing this update, for us to be able to tell you, these are the algorithms. And that's what they're trying to do. Now, when those algorithms come out, guess what? You're going to need to replace every single certificate you have. Every certificate type, every environment, public or private, They will all need to be replaced. So that will be a very important initiative when it comes, and timeliness will be important because quantum computers are continuing to advance. They're not slowing down. And even if there isn't a quantum computer that can break your SSL session a year from now, how do you know that some advanced attacker isn't storing encrypted files that they're getting by snooping on your environment and just waiting 5 years until they're able to use a quantum computer to open them then? And some of our secrets won't be valuable in 5 years, but some of them will. And so what we really need to do is we're going to need to be able to move fast. As soon as the algorithms are ready and the software and hardware can support it and the certs are being issued by public CAs, you're going to want to take those and you're going to want to change them out and move to quantum ready certificates in your environments. Do you want to add anything to that, Nick?
Yeah, I was going to say, well, I think to my mind, you touched on very kind of important point at the end is, well, while timeliness is absolutely very important, the last couple of sentences you said there is NIST obviously want to get this out as soon as possible. And the reason they want this to happen as quickly as possible, not just because of the impending threat of quantum computing, but they also know, as I think we need to explain to everyone, is that there is I hasten to call it lag, but there is a delay between NIST rubber stamping these algorithms and that rollout you mentioned of things like hardware and software and everything else, because NIST could finalize these algorithms tomorrow. Or Friday, they could say, right, here's the absolute NIST recommended standard for post-quantum encryption. Great. There we go. There's a reference implementation. A bunch of things need to happen before Sectigo or any other CA can start to issue certificates for it. Obviously we need more than just one implementation, so people need to start writing software for it. That then needs to be incorporated into the browsers and into clients however they choose and however they see fit, and standardized as part of their programs. We need to build out our software to be able to support it. And I think critically, but it almost seems like a small point, is hardware. A lot of what we do, it comes down to hardware. We're required to keep all of our super secret encryption keys for our routes and our issuing CAs in specialized hardware. I mean, you may or not be all aware of something called a HSM, a hardware security module. And, these are like hardware devices or appliances that are designed to securely store keys and never let them out. They can be used, but they can't be extracted. And, they honestly have crazy features on them that sound like something out of a James Bond or a Mission Impossible film. You x-ray them, or you take them too close to a magnet, or you heat them up and they automatically erase their contents. But those hardware pieces are critical for the operation of a CA. And so we need the hardware vendors to get into a state where they can support these algorithms. And, I guess what I'm kind of saying is, as much as NIST could announce this in early 2022, I think, people still need to understand that there may be a reasonable amount of time before they can actually get a certificate and make it usable. Now, as I think we'll see on the next slide. Yeah.
What can you get now? What you can do now is you can start. So there's a few ways to start, one of which is just to get educated. So we have a focused area in our online site, sectigo.com/quantum-labs. And that is where we collect a lot of information and assets about the quantum computing and quantum safe certificates and what's going on with that. So first thing is just get educated. Go there, dive into those assets, read the white papers, watch the videos, listen to the podcasts, and you will learn, right? And look at the date, right? This is a moving item, so something from a year ago is probably less informative than something from a month ago, right? Because things are changing. But it's good to look at that and understand the landscape and know what you think is coming and be able to articulate this and express this, right? Because you probably have people up the management chain from you. You have people with C's in front of their titles. You have people on the board of directors who don't necessarily know about this and don't understand that this is coming and don't understand that the organization needs a plan and don't understand that the organization needs a plan for something that now is happening in a year. When we first started talking about this, it was happening in 4 years, right? But now it's happening in a year. So, that's a very different thing. So it's good to get educated and be able to articulate to the organization what's going on. And then the other thing that's really important is that you can get our quantum state certificate test kit. You can download that. It's free to anybody. And you can actually use that to issue hybrid certs that will include an RSA or ECC algorithm, but also one of the candidate algorithms for your own private routes. You can't use it for a public route because those certs aren't available yet, not approved, but you can do those off your own private routes if you want. And you can actually start testing and development, put them in a sandbox, see what they do, see how they work, see how they operate with your existing systems. And that's something you can start doing today to start to understand what these things really are and how they work. And so those
Absolutely.
are some recommendations we have.
Yeah.
So
these hybrid certificates are actually really good to test because, as the name suggests, they're designed to work as they should today. I mean, with your standard browsers and your standard servers and everything, that's with the tools in the test kit, you can do that. But because they are a hybrid certificate, they will still work with the existing browsers and things that you have, but you can still test the fact that they have these post-quantum keys embedded within them. And so it's an interoperability test, and it's always good to make sure that, much like we keep saying about agility, that your existing systems can handle changes, especially new things. This is new. There isn't really anything like this. This isn't a shift from SHA-1 to SHA-2 or, bigger key sizes or shorter certificates. This is a fundamental shift. Bless you, Tim. Fundamental shift in how certificates and keys are actually issued. And so this is a great test, especially on legacy gear, legacy equipment that's critical to you, to be able to test as to how that reacts to what is very rapidly going to become a new standard for everything.
Yes. So what are the recommendations? I think we already touched these. Number one, have a quantum ready initiative. We're at the point now where every large enterprise should know this is coming. There should be somebody who is tasked with understanding it and tracking it and looking at potential dates and timelines and start to formulate your plans, right? Nobody's going to have to act on this year, but it's good to start making these plans. And again, teach the organization that this is coming and it will come, and this is why it matters. And when it comes, this is why we're going to need to act on it. Conduct an inventory of your certificates, right? Know what you have. What are your certificates? What are your CAs? What are your private keys? You can't afford to miss anything. So when the time comes to do it, you got to get them all. So you should know what they are. Go ahead and download and install the Quantum Safe Kit and play around with it, figure out what it does. And visit sectigo.com/quantum labs. Just to keep current. So those are recommended actions. I'm going to do my plug I always do. If you did like this conversation, then one of Nixon and my associates, Jason Sirocco, and I run a podcast called Root Causes, the PKI and Security Podcast, where we dive deep on all aspects of PKI, digital certificates, encryption, blockchain, and things along those lines. And we would love to have you come join us. So with that, I think we're ready for questions. I know we're really running short on time. Kristen, do we have any, or Megan, do we have any questions?
Yeah, we have a few questions.
Okay, go.
The first one is, what are the ways my operations might be dependent on OU fields today?
Yeah, so I think that might have come in before we hit that slide. But we touched on that a little, right? You might have software that is looking for the contents of an OU field in order to make a decision, to take an action. Like for instance, if this doesn't have this in the OU field, then lock it out and don't use the cert. It's kind of a different version of certificate pinning. And that's a thing that could be happening. We've seen that. Or the big one is it's a process thing. Again, it's like I use this to determine where to provision this cert, or I use this to determine who has the rights to provision the cert, or I use this to determine how to bill for this cert. And those are all things where it's not that your technical systems are going to stop running, but your process is going to shut down and not run correctly. And so those are the two things to look at. Those are the two areas to investigate, I would say.
Yep, agreed completely.
Cool.
All right. Are other root trust deprecations on the way?
Honestly, we don't know. I would suggest though that yes. I mean, what The reason it's a bit difficult to tell is we know what Mozilla are planning to do because Mozilla are an open organization, right? So they conduct their business out in the open with public discussion, public input, and on public mailing lists.
Right.
The likes of Apple, Microsoft, and to an extent Google, although they are partly visible through representatives that participate with Mozilla, they're closed. So we obviously have relationships with them, but they don't always disclose what their long-term plans are, much like they wouldn't about any of their products to any of their other partners. However, what we do tend to see, especially with things like this, is Mozilla will have the public discussion, and it is something that's being thought about and discussed at the other closed organizations.
Yeah.
So I think we can probably expect similar effects to be had with other trust stores, although we really don't know who and when necessarily.
If
Tim?
nothing else, because the other root programs are all watching what they're doing. So the fact that Mozilla is talking about this publicly means that the other root programs are well aware of these conversations and they're following them closely. And everything that's being said on the public Mozilla fora is being observed by Apple, Google, Microsoft, Cisco. And we've also seen that once a major root program sort of puts a limitation in place, there's a strong tendency for other programs to line up with them. And the case study on that was Apple and one-year SSL certs. So last year, Apple announced that they would move to one-year SSL certs, and they laid out a very specific set of requirements in terms of how they were going to do it and what the certs needed to look like. And we saw that the other major programs completely lined up with them. So we watched Firefox and Google just identically match Apple's requirements in every way. And that, and that shows how closely they pay attention to what they're doing and how much they value having consistency across multiple root programs for the same treatment of certificates. So yeah, I'd say that is a very real possibility. Nobody's said anything publicly yet, though. So next question.
All right, this is the last question.
Okay.
Is there a chance that quantum computers never get to the point where they beat RSA and ECC?
When I talk to people about this, I sometimes get that objection. I get people who push back on me and say, "No, that isn't really going to happen." I think it's really going to happen. I know there are some people writing online who want to be skeptics and naysayers, but this isn't a science problem anymore. Now it's an engineering problem, which is to say, multiple efforts across multiple organizations, both universities and large technology providers, have proven that they're able to do this. That isn't really, it's not theoretical anymore. There have been plenty of computers, there are plenty of quantum computers that operate in plenty of places, plenty of labs around the world, and they're all just racing with each other to see how many qubits they can stabilize.
Yep.
And that means that's going to keep going. It's the inexorable march of technology. So we can wonder how fast it'll go, and that's a legitimate question. And exactly when do quantum computers reach the point where they hit that critical mass is something a lot of people wonder about and speculate on, but nobody could really know. But at this point, I think if you're going to contend that this might not happen, you're just putting your head in the sand. Like, it's
I think
going to happen.
Yeah, I think the other thing to bear in mind is we may be expecting this idea of like a quantum apocalypse, right? An event that happens very, very quickly, and that may still happen. But my suspicion is that, as you said, Tim, this is progressing, right? We know it's happening today. It's getting better and better. It may get to a point where it's feasible to break RSA. And when we say break RSA, that doesn't mean someone can click the fingers and have it broken in milliseconds. It might be that an RSA key is factorable in 3 months if you have a nation state size budget, for example. So it's broken. There's no question it is broken, but it's at a limit where only certain entities can actually do it. And we need to determine, well, who's that a threat to? And arguably it could be anybody. And so
target list there would be lower, right? Because, nation state isn't going to bother trying to steal your login to Facebook. But over time, as those computers get better, the realistic threat footprint will go up. Right?
Yes, absolutely.
And that's how it's really going to go. Yeah. But it will happen. I mean, it is happening. So no, I mean, I think you need to be prepared, and I think you need to have your plan, and I don't think we can talk our way out of this one.
Absolutely.
That's it for questions. As always, thank you, Tim and Nick. And thank you, everyone, for joining us.
Thank you, Megan.
Thanks, Megan. Thanks, Tim. And thanks,
We'll
everybody.
be sharing today's webinar recording tomorrow, so be on the lookout. Thanks again.